Now, look at example 1 here. And over to the right-hand side of this paper, I'm going to go ahead and write the rules to naming. I'm just going to write them right down the right-hand side of this paper. So, these are your rules. If you are naming an ionic compound, this is what you're going to do. You are going to name the cation. And the cation will always be listed first because it's the metal. The metal always comes first. Like if you look at all of these all these compounds, all of them have the metal written first. And that's the way that it should be. The names, same way. The cation or the metal always goes first. You don't change anything about the name of the cation. Just say the name of the cation. Like, you all know sodium chloride, NaCl. When you say that, you just say the word sodium, okay? It's just the name of the first element. All right, then, second thing, you are going to name the anion, which is the second element. Okay, name the cation, then name the anion. And the third thing, you are going to change the ending of the anion to IDE. All right? Everybody with me on that? Yeah, Maddie.
So let's say it's like hydrogen chloride or chlorine,
Mhm.
and it's hydrogen chloride.
Yeah. Yeah, so like with sodium chloride, you name the first element, sodium. You name the second element, which would be chlorine, but you change the ending of it to IDE. So that becomes chloride. Okay? Ava.
Is that an A? Right
Where?
there instead of a, is it ion right there?
Anion?
Oh, sorry, my bad. Where?
Right here.
On the right side of the board. Oh, okay.
All right. Now, it would be helpful for you to have out a copy of the periodic table because there's a couple of things I'm going to show you on there. If you do not have a copy, there's some extras right here. Kalia?
I was just gonna ask if I could look up one on my Chromebook.
That's probably not going to help you too much because you need to write some stuff on it.
Oh, okay.
All right.
Okay.
Now, the periodic table is very helpful in the way that it's set up because stuff is very predictable. Okay? There's a lot of patterns that occur. All right, so if we look right here, look at group 1. Guys, how many valence electrons does group 1 have? Just 1. When group 1 forms an ion, it's going to lose that 1 electron, so this forms a positive 1 charge. Everything in that group will form a positive 1 charge when it forms an ion. So what do you think group 2 is going to form? Positive 2. The periodic table on the wall over there, it actually has all those labels up at the top. What do you think group 3 is going to form? Positive 3. It has 3 electrons in its outer shell. It wants to lose those 3. Ava?
I have a question. Why don't we do like the middle one right there?
Transition metals are complicated. Okay, we're not really worrying too much about those right now. All right, group 4. Now, group 4 is right in the middle. If it ionizes, which is an if, a lot of times it'll form a covalent compound. But if it ionizes, it could be a plus or minus 4. It could lose 4, it could gain 4. Either way. Don't throw that.
What's happening?
All right. Group 5 is going to be a -3 charge. Group 6 will be -2. And group 7 will be -1. Okay? Everybody with me? It's all based off of how many electrons they either gain or lose. If they lose, they're going to be positive. If they gain, they're going to be negative.
Can you
Ava.
go back to the side a little bit? Like,
All right. So take that periodic table and just sit it next to you because it'll be helpful once we get to the chemical formulas. Now, we're going to write the names of some of these, and it'll be helpful for you to have the names right next to you on your periodic table. Also, so the first one, you have RBBR. What is RB? Connor? Rubidium. So you just name the name of the cation. Rubidium. And then what is BR?
Bromide.
All right, so it's going to be bromine, and then you change the ending of the name to IDE, so it becomes bromide. So rubidium bromide is going to be the name of that compound. Now, real quick, before we go any further, I'm actually going to go through on your non-metal side, and I'm going to actually tell you what the names of each of these would be when they become an ion. So this becomes the iodide ion, bromide, chloride, fluoride. Like you've heard of fluoride before, like in toothpaste. Those are fluoride ions. Oxide, sulfide, selenide, telluride, arsenide, phosphide, nitride, carbide, silicide. Okay? And that's really it. Okay, let's look at number 2. What is Ra? Radium. And what's I? Iodine, and it'll become iodide. So that is radium iodide. That's how you would name that.
Iodidazole.
All right. Number 3. What is CS?
Celsium?
Cesium. Cesium is right here. First column. And what is Se?
Selenium.
Be selenium, which becomes selenide. So cesium selenide is going to be your answer there. All right, let's go ahead and jump down to number 4. What's Al? Aluminum. Okay, aluminum, and then what is I? Iodide. Aluminum iodide. Okay. We'll do one more and then we're going to go down to the bottom. What's Ag? Silver. And what is Br? Bromine, which becomes bromide. And that's it. Anybody have any questions about any of those? So you just name the cation, then name the anion, change the ending of the anion name to IDE. All right, go ahead and jump down to the bottom. A lot of times writing the formula is a little bit more complicated. So I'm going to show you the long way, and then I'm going to show you a shortcut.
Is this on the same page?
Yeah. So I want you to understand why we do this the way that we do with the long way, but then I'm going to show you a shortcut here in a minute. So let's take sodium iodide. Now, sodium is Na. What is or how many valence electrons does sodium have? Look at your periodic table. Sodium has 1. It's in group 1. So 1 valence electrons. And iodine has how many? Well, it'd be a -1 charge, but it has 7 valence electrons. So it's going to look like that. So how many does sodium want to give up? 1. How many does iodine want to gain? 1. So what's going to happen is sodium's going to transfer this electron over to iodine. The formula is 1 sodium to every 1 iodine. So it's NaI. So up here, we'll write that in. Okay, NaI. Everybody with me so far? All right. Now, 27, we have barium bromide. Barium is Ba. How many valence electrons does barium have? Barium, right here. 2. 2 valence electrons. And how many does bromide have? 7. 1, 2, 3, 4, 5, 6, 7. So how many does barium want to give up? 2. How many does bromine want to take? 1. That's a problem. So barium's going to give up 1 electron to bromine, but bromine can't take any more on. So what happens is another bromine atom comes in and is needed to satisfy this reaction, because barium can give up 1 more, bromine takes it. Now the formula for this is BaBr2. Now why? Because I have 1 barium atom and 2 bromine atoms, bromide ion.
Oh, I see how.
Okay? The number always comes after the element that it's describing. So that means 2 bromide ions. So right here, for barium bromide, we would put BaBr2. Everybody with me so far? Anybody not with me? All right, I'm going to show you one more example, and then I'm going to show you the shortcut. So we're going to look at number 31, calcium phosphide. Calcium is Ca, phosphide is P. So how many valence electrons does calcium have? It has 2, because it's in the second group right here. So it's got 2 valence electrons. How many does phosphorus have? Phosphorus is right here. 5. It's in group 5A. So 1, 2, 3, 4, 5. All right, now, calcium wants to give up 2. Phosphorus wants to take 3. Oops, sorry. So calcium's going to give up 1 and 2. Now, calcium is happy. Phosphorus is not. So you have to bring in another calcium. Calcium donates that one electron there. Now, calcium is not happy, but phosphorus is. So you got to bring in another phosphorus. Okay? This electron right here goes to phosphorus. Now, that calcium's happy. It got rid of the two that it had, but phosphorus is not happy. It still wants two more. So calcium, another calcium, comes in, donates an electron there, and donates an electron there. Now everybody's happy. So the formula, how many calciums do I have? 3. So you have Ca3, and then how many phosphoruses? 2. So Ca3P2 is going to be my formula. Everybody see where I'm getting at?
Yes, this is a little complex.
Okay. So up here, I'm going to write that in. Ca3P2. All right, I am going to show you a shortcut that is much easier, much shorter. All right, look at number 29, potassium selenide. Okay, what is the normal charge on potassium? Potassium's right here. Charge is +1. Everybody understand that? Okay. So write the charge. Okay, just like that. What's the charge on selenide? Selenium is right here. Charge is -2. Everybody see where I'm getting at?
Yes.
So write the symbol with the charge. Okay, now this is called the crisscross method. What you're going to do is take the numbers and crisscross them for your formula. So potassium gets a 2, selenium gets a 1, which you don't need to write. So that's your formula, K2SE. All right, does everybody understand where I got those numbers? Okay, I just took the charges and I just crisscrossed the numbers. Now, guys, when you write a formula, there are no charges included in the formula. So these are charges right here because these are charges on the individual ions. However, once it's in the formula right here, you no longer show the charges. Okay? Because it's neutral. The reason it's neutral is because now you have 2 potassium ions that are both +1 and 1 selenide ion that's -2. Well, 2 +1s and 1 -2, that cancels out. Because you have +2 -2. Cancels out. It's neutral. All right. Let's look at another example here. Let's look at 30, strontium hydride. Now, strontium is what charge?
Strontium.
SR. It's +2. Okay, right here. So strontium, +2. Now, hydrogen, in this case, this is kind of an exception to the rule. Normally, you would think hydrogen, +1. However, hydrogen is a special case because hydrogen has 1 electron, it only wants 2. So what can happen is hydrogen can either gain 1 and fill it up,
Or lose it.
or it can lose 1 and empty it out. So hydrogen sometimes can gain one, form a negative ion. Sometimes it can lose one, form a positive ion. I would say more times than not, you're going to have a positive ion with hydrogen, but in this case, it's a negative ion. So hydrogen's actually going to form a -1 charge. Okay? So we crisscross the numbers. Strontium gets the 1, hydrogen gets the 2. And that's going to be our formula, SRH2. All right, everybody with me so far? All right, there are a couple of real simple exceptions to this rule. Times when crisscrossing is not going to completely work. And here's a couple of examples. So let's say that we had magnesium oxide. So magnesium is +2 and oxygen is -2. Okay? Everybody understand the example? So when I crisscross these, it's going to give me Mg2O2. That's not right because it needs to be reduced. Everybody knows what the word reduced means in math? Like if you have two numbers that can both be divided by the same number, you have to divide them. So these are both divisible by 2. So the formula is actually MgO. It's a 1-to-1 ratio. I only need one +2 and one -2 to balance this out. I don't need 2 of each. So that's going to be my formula. Another example of this would be if you had a +3, -3. Like aluminum is a +3, phosphorus is a -3. When you crisscross this, you would think, oh, it's Al3P3. But that's not the case. It's actually just ALP. Because you reduce it. The only other place where you would potentially see this is if you had a +4, -2, which lead can form a +4 charge a lot of times. And a lot of times it'll pair with oxygen. So lead oxide, you could get a +4, -2 charge. So we crisscross these, we get Pb2O4. However, both of those numbers are divisible by 2, so we reduce it to PbO2, and that's actually my formula. I mean, here's the thing, guys. If you did not reduce it, you would get partial credit, but you would get some points taken off for not reducing it. So make sure that you reduce whenever you do any of these. Okay, I'm going to go ahead and circle some of these that I want you to do on your own. And that is homework, which you have 18 minutes. You should be able to get this finished before you leave. So the ones that I want you to do for homework are number 6, 7, 8, and 10. 6, 7, 8, and 10.
How many? How many is that?
That's 4. 6, 7, 8, and 10. Okay? And then on the bottom, I want you to do 32, and 33. And those are probably only going to be the ones that you can do right now. Yeah. So Go ahead and do those. That gives you 6 problems. Okay? You should be able to get those finished before you leave.